Good morning students. In the previous class we see some basic formulas. Now in the next exercise we see some composite functions. In previous we see just only one function. A composite function means, I give one example. We know very well the integrating of the sin x is minus cos x. Let's see. Suppose instead of x, sin 6x dx. So this kind of function is called implicit or composite function. In place of x here 6x. So in this sum, how to solve? First of all, we consider the 6x is x. The integrating of the sin x is minus cos x. So minus cos 6x. It's an important rule in integration. Suppose the given function is in composite. First we using the basic formula of a sine we use. Next one, instead of x here 6x. So we differentiate this 6x with respect to x. We put the answer in denominator. So the differentiating of 6x with respect to x, 6 is a constant. But the 6 is multiple with the variable, so we keep 6 as it is. The differentiating of x with respect to x is 1. Let's see. So the answer is minus cos 6x divided by 6 plus c. Suppose the given function is given in composite, it is the working rule. I'll give one more example. Sin of ax plus b. What is the integrating of sin of ax plus b? Here a and b is the constant and x is the variable. What is the integrating value of this one? First of all, we are using the basic formula. The basic formula of sin x is minus cos x. But in place of x here, ax plus b. So the first step is minus cos of ax plus b. What is the next step? It is a composite function. Instead of x here, ax plus b is there. So to differentiate the another function, the bracket one function, with respect to x, we put the answer in denominator. So ax plus b, we already tell in ax plus b, a and b are the constants. X is the variable. So whose differentiating is a into 1. Okay, a is a constant, is multiple with x, so a. X with respect to x is 1. Plus b whole is a constant, so whose differentiating value is 0 plus c. So the answer is minus cos of ax plus b divided by a plus c, or we write minus 1 by a of cos of ax plus b plus c. So it is a working rule to solve the given function in composite. Now we see some sums all are involving composite. In same exercise 11.2, you see the question, evaluate the following with respect to x. We already tell. In another way, how to give the given question? Evaluate integrating symbol with respect to x dx. Now given in bad, we evaluate all the given one with respect to x. Now we solve the first one. Integrating x plus 5 whole power 6 into dx. Evaluate, or we integrate the term with respect to x. Now we need this integration. What is the basic formula of this one? Base x variable is contained. So x power n. But it's not only x plus 5 is there. So first we are using the basic formula of x power n. You memorize the formula? We already tell the formulas are very important. The x power n integration formula is x power n plus 1 divided by n plus 1. Here in place of n, 6 is there. So x plus 5 whole power 6 plus 1 divided by 6 plus 1. First of all, I use x power n formula. So x power n plus 1 by n plus 1. But it is a composite function. It's not only x is there. X plus 5 is there. So we are differentiating the base term with respect to x. What is the first term? X. The differentiating of x with respect to x is 1. Plus the differentiating of the constant 5 is 0 plus c. So the answer is x plus 5 whole power 6 plus 1 is 7. Divided by 6 plus 1, 7, just 1. So x plus 5 whole power 7 divided by actually 7 into 1. 6 plus 1, 7 into 1 plus c. So the answer is x plus 5 whole power 7 divided by 7 plus c. So it is the integration value of the first one. Now we see the second one. Integrating of, you see the question, 1 divided by 2 minus 3x whole power 4. 1 divided by 2 minus 3x whole power 4. It's not only x here. Suppose just 1 by x is the integrating of 1 by x is log modulus x. But 1 divided by 2 minus 3x whole power 4, we integrate. So the first step is, we keep the term denominator goes to numerator. The denominator term goes to numerator, then the sign change in the power. So we write it is 2 minus 3x whole power minus 4 into dx. The denominator plus 4 suppose goes to numerator. The plus 4 become minus 4. Now using the same formula of x power n, because in base the variable x is contained. In power the constant minus 4 is there, so using first of all x power n form. But the base is not only x, 2 minus 3x composite function. So first we are using the basic formula of x power n. The value of x is here 2 minus 3x and the value of n is here minus 4. So x power n integration formula is x power n plus 1 by n plus 1. So 2 minus 3x whole power minus 4 plus 1 divided by minus 4 plus 1. First of all I use x power n formula. X power n plus 1 divided by n plus 1. Again we are differentiating the base term with respect to x. What is the base term here? 2 minus 3x. Now we are differentiating it with respect to x. First term is 2. The differentiating of the constant 2 is 0. What is the sign here? Minus. What is the differentiating of 3x with respect to x? 3x with respect to x is just 3. We keep 3 and x with respect to x is 1 plus c. So it is a working rule to integrate the composite function using the basic formula of x power n first of all. And again we differentiate the base term with respect to x, we put the answer in denominator. So 2 minus 3x whole power minus 4 plus 1 minus 3 divided by minus 4 plus 1 minus 3 will use 0. Minus 3 into 1 is again minus 3 plus c. So 2 minus 3x whole power minus 3 divided by, actually minus and minus is plus 9 plus c. But in power numerator minus sign is there. So again the minus term comes in denominator, it becomes plus in the power. So we write it is 1 divided by 9 of 2 minus 3x whole power 3 plus c. So it is the integrating value of the second one. Now you see third one, you have any idea? What is the third one? The third one is, we find the integrating of square root of 3x plus 2. Square root of 3x plus 2. The first step, we write a square root as 3x plus 2 whole power 1 by 2 into dx. You know very well, square root is the, we write it is whole power 1 by 2. Now you have any idea? Using the same formula of x power n. But the base is not only x, 3x plus 2 and power 1 by 2. So 3x plus 2 whole power 1 by 2 plus 1, that is x power n plus 1 by n plus 1. Okay, next. Again we are differentiating the base term with respect to x, we put the answer in denominator. So 3x plus 2. Suppose you know very well, just you write only one line. The differentiating of 3x plus 2 with respect to x is, I said, 3. We check it is correct. The differentiating of 3x plus 2 with respect to x is just 3. 3 of x with respect to x is 1 plus 0. So the answer is 3 plus c. 3x plus 2 whole power. Okay? Half plus 1 is 1 and half is nothing but 3 by 2. Divided by 3 by 2. Okay? Half plus 1, 3 by 2. Again 1, 3. Actually this 2 goes to numerator. So you have the constant. So 2 of 3x plus 2 whole power 3 by 2 whole divided by this 2 only goes to numerator. 3 3s are 9. So 9 plus c. So it is the integrating value of the third one. So it is a basic rule or basic simplification. Suppose the given sum are given in some composite function. What is the first step? To integrate the basic formula, and again to differentiate the composite function we put the answer in denominator. And next the fourth one, integrate the following with respect to x. Already we see we integrate the same term with respect to x. Secant square of x by 5, and you see the second subdivision, the same model sum we already put in the previous question. So you try. The third subdivision, 30 secant of 2 minus 15x into tan of 2 minus 15x. We integrate the term with respect to x. So integrating of secant square of x by 5 into dx. Okay, secant square of x by 5 into dx. In place of x here, x by 5. So first of all we treated it is x. The integrating of secant square x is tan x. So tan of x by 5. Okay, wow. But it is composite function. In place of x, x by 5. The next step, we are differentiating x by 5 with respect to x. We put the answer in denominator. So x by 5 differentiation we need. So 1 by 5 constant. And x with respect to x is 1 plus c. So tan of x by 5 by 1 by 5. Now this 5 goes to numerator. So it becomes 5 tan of x by 5 plus c. So it is the answer of the first one. Next, third subdivision. Our given question is integrating of 30 secant of 2 minus 15x into tan of 2 minus 15x into dx. We integrate the term fully with respect to x. We see the constant 30 is multiple with this variable. So the first step, we will take outside the constant. Suppose the variable is multiple with the constant, we will take the outside the constant. 30 secant of 2 minus 15x into tan of 2 minus 15x into dx. So outside 30 I put 30. Secant we treated it is x. Tan we treated it is x. Integrating of secant x tan x is secant x. So secant of, but in place of x, 2 minus 15x. So okay. Numerator over. What is the denominator? Is a composite function. So we differentiate the term with respect to x. We put the answer in denominator. 2 constant 0 minus 15 of 1. Okay. Constant 0 minus 15 is a constant. We keep 15. X with respect to x is 1 plus c. So 30 secant of 2 minus 15x whole divided by minus 15 plus c. Exactly in second table. Twice In standard form, we keep the minus sign in numerator. So minus 2 secant of 2 minus 15x plus c. So it is the integrating value of the third subdivision. In second subdivision, the same model, we already see one example sum. So you try the remaining sums. Next we go to the fifth one. All the terms are integrating with respect to x is the question. So integrate the following with respect to x. So there will be three subdivisions is there. First we see the first one. Integrating of sine of 2x plus 4 into dx. So composite function. What is meant by composite function? Instead of x, some more term is involved. So except x, so many terms are some added or multiplied. Then we say the function is called a composite function. So first we are using the basic formula for sine. You treat it fully, it is x. What is integrating of sine x? Minus cos x. So minus cos of 2x plus 4. So basic formula. What is the next step? It is a composite function. So the next step is we differentiate the term with respect to x, and also we put the answer in denominator. So whole divided by 2 of 1 plus 4 is a constant lies alone, so 0 plus c. So is your choice. We write it is minus 1 by 2 of cos of 2x plus 4 plus c, or minus of cos of 2x plus 4 whole divided by 2. Is your choice. We write any manner. Minus cos of 2x plus 4 whole divided by 2, or minus 1 by 2 of that. So it is the integrating value of the first one. Now we move the second one. What is the second one? Integrating of secant square of 3 plus 4x into dx. So integration formula is very important. Suppose you don't have the formula, you don't find the answer. So integrating of secant square of, you treat it is fully x. So what is the integrating of secant square x? It is just tan x. But instead of x here, 3 plus 4x. So first using the basic formula of the secant square x. Integrating of secant square x is tan x. But in place of x here, 3 plus 4x, so we write it is tan of 3 plus 4x. What is the next step? It's a composite function. So we differentiate the bracket one term with respect to x. We put the answer in denominator. I say just 4. We check how it is 4. 3. How long is a constant whose differential value is 0. Plus 4 of x with respect to x is 1. So just 4 plus c. So we leave as it is. Okay, it's also answer. Or 1 by 4 of tan of 3 plus 4x plus c is our choice. We write in this 2 step. So it's also answer. Or sir, I write just a constant. I solve 1 by 4. So you write in this manner also. Next, we see the third one. Integrating of cosecant of ax plus b and cot of ax plus b. Suppose we using the symbol of this integration, this dx term is very important. That means we are integrating all the term with respect to x. Okay. What is the basic formula of integrating of cosecant x cot x? Integrating of cosecant x cot x formula is a minus cosecant x. But in place of x here, ax plus b. So first we write minus cosecant of ax plus b. Formula power. But it is composite. What is the next step? So accept x here, ax plus b. So we differentiate the term with respect to x. So a of, always in ax plus b, we treated a and b is a constant and x is a variable. So a of 1 plus 0 plus c. We leave. So the answer is, I write minus 1 by a into 1 is a. Cosecant of ax plus b plus c. So in all the sum, formula is very important. So you first memorize all the formulas. Okay, we see the next one, fifth one. All the terms are integrating with respect to x. So 1 divided by square root of 1 minus 4x the whole square. You see the sign is a 4x the whole square. 81x square. 36x square. So first step we converted in the formula shape. Integrating of 1 divided by square root of 1 minus 4x the whole square into dx. Suppose x is there. We already see the formula. Integrating of 1 divided by square root of 1 minus x square is a formula of sine inverse of x. But instead of x here, 4x. So it's also a composite function. So first we see the basic formula. So sine inverse of 4x whole divided by, in place of x here, 4x. So we differentiating this 4x with respect to x. We put the answer in denominator. 4x with respect to x. So the answer is 4 plus c. So we leave or we write it is 1 by 4 sine inverse of 4x plus c. So it is integrating value of the first one. Now we see the second one. Integrating of 1 divided by square root of 1 minus 81x square into dx. You know any difference between 1 and 2? In 1, whole square is there. But in 2, 81x square is there. So first we convert the formula shape. We have the formula of 1 divided by square root of 1 minus x square. So the square is common. But the square is only for x. So you have any idea? So 1 divided by square root of 1 minus, how to write 81x square in the whole square? 81 is also f of x square. So we write 81 as 9 square. Already one x square is there. So we write it is 9x the whole square into dx. 9 square, 81, x the whole square, x square. Now it exactly comes in the formula. So we write sine inverse of 9x. Basic formula we use first. 1 divided by square root of 1 minus x square. Sine inverse of x. In place of x, 9x. Next, we are differentiating this 9x with respect to x. We put the answer in denominator. So 9 plus c. So it's also answer. Leave as it is. Or 1 by 9 into sine inverse of 9x plus c also. We write. Now we see the third one. Integrating of 1 divided by 1 plus 36x square into dx. We already see the two sums. You must have some ideas. Yes, the first step is 36x square. We write the 36x square as 1 plus 6x the whole square. Okay, we write 36x square as 6x the whole square. So it exactly one formula shape. What is the formula? 1 divided by 1 plus x square. 1 divided by 1 plus x square. Basic formula is tan inverse of x. But in place of x here, 6x. So tan inverse of 6x. Then 6x. The differentiating of 6x with respect to x is 6. So whole divided by 6 plus c. Or we write it is 1 by 6 of tan inverse of 6x. So Allah is one. We very well know the formulas. So the first step to convert the formula shape. The next one we are using the formula. So we finish the second exercise. You must try the left sum of the examples and also in exercise.